Good morning, everyone. My name is Shamil, and welcome to the second video for Fire Alarm Systems 101. And today we will be discussing about the topic the fire triangle. So let us explore what is fire triangle. So a fire triangle is actually a model. It's a simple model which explains the three essential elements that are needed to form a fire. So the fire triangle is basically a recipe for fire. So it tells us what all ingredients are required in order to make a fire. Okay. So the golden rule for a fire triangle is that if you remove any one of the elements, the fire will be extinguished. Okay. In order for the fire to exist, all the three elements should be present. If you remove any one of them, then the fire is extinguished. And the fire triangle is considered to be the foundation for the fire detection and fire suppression systems. Okay, so next slide. So, as I said, it is a fire triangle, and the fire triangle consists of three sides. So, let's name each side. So, the first side, side 1, is called as the oxygen, the side 2 is called as heat, and the side 3 is called as fuel. Okay, so in simple terms, for a fire to exist, there are three elements which needs to be present. The first one is oxygen, the second one is heat, and the third one is fuel. So if each side of a triangle is represented by an element, by that particular element, oxygen, heat, and fuel, then we get a fire triangle. And as I said before, in order for a fire to exist, all these three elements should be present. If you remove any one of these elements, then the fire will be extinguished. So that is the concept behind fire triangle. So let's discuss about the first side, which is the oxygen. So what is or where do we get oxygen? The air around us. That is the simple answer for the source of oxygen. So oxygen in our atmosphere is around 21%. Okay, 21% out of in the atmosphere, this thing. And what is the role of oxygen in the fire? So the fire needs oxygen to sustain the chemical reaction of combustion. Okay, in order for the fire to exist, oxygen is required. So some of the examples for suppressing a fire is that, for example, in case if you're cooking something inside in the kitchen and suddenly a fire comes out of a pan. So in order to extinguish the fire, what you do is you actually cover the pan with the lid, okay, so that you are cutting off the supply of oxygen from the fire. The second one is uh, you have these extinguishers, that is the carbon dioxide extinguishers, CO2 extinguishers. So when you discharge the CO2 content towards the fire, the CO2 actually displaces the oxygen in order to extinguish the fire. That is the principle behind the carbon dioxide extinguisher. So basically, it is like smothering. That action of displacing the oxygen from the fire is called as smothering. Okay. Now, let's discuss the side 2. The side 2 is going to be heat. So, what is heat? Heat is actually the ignition source. So, it is basically the energy required to raise the fuel to its ignition temperature. Then only the fire will be formed. So, what are considered to be the sources of heat? So, you have matches, matchsticks, lighters, electrical sparks, overloaded circuits, friction, lightning. Okay, these sources are considered to be heat sources. Okay, so what is the role of heat in fire? The heat actually starts the fire and it keeps it going. So for the oxygen was to sustain the chemical chain reaction. Okay, the role of heat in the fire is that it's to start the fire and keep it going. Okay, that's the role of heat in fire. So how can we detect heat? In order to detect heat, we have a set of detectors that is specifically for sensing the heat. So these are called as heat detectors, and the heat detectors comes in two types. So there is a rate of rise. There's a heat detector which senses the rate of rise. That is, it measures how fast the temperature rises. Okay. Then there is a heat detector which senses whether the temperature of the fire has reached a set point. So that is called as fixed temperature heat detector. So we had two types. One is the rate of rise heat detector and the other one is the fixed temperature heat detector. Okay. So many a time, like these days, commonly we get both the sensors, both the types in a single detector. Okay. So that is called as multi-heat detector. So this is the detection principle for the heat. Now, how do we suppress heat? So to suppress heat, we pour water, as simple as it is. So when we pour water on the fire, the temperature lowers and you actually eliminate that element by by discharging water. The last side of the triangle is the fuel. So what is fuel? Fuel is actually any combustible material that will burn. That is called as fuel. So there are three types of fuel. You have solid, liquid, and gas. So what are considered to be solid fuels? You in solid fuels, the examples are wood, paper, cloth, and plastics. Liquid fuels are basically gasoline, oil, paint, and alcohol. Gaseous fuels are basically propane, natural gas, and hydrogen. Okay, these are some of the few examples of the fuel. And what is the role of fuel in fire? In fire, if any fire occurs, it is the fuel that actually burns. Okay, that is the role of fuel in the fire. Okay, so fuel is nothing but the substance which burns. Okay, so how do we detect fuel? There is no standard fire alarm devices which detect fuels. Okay, but we actually detect the byproducts of burning fuel, such as smoke, heat, and flames. Okay, these are some of the byproducts when you burn a fuel. Okay, so now there are exceptions, like there is a leak detection system. That is when the fuel is leaking somewhere from the system, we have a separate device for that. But in terms of detecting a fire from a fuel, we actually detect the byproducts of the fuel, such as smoke, heat, and flames. Now, how do we suppress this element that is a fuel? So, the some of the examples are like turning off the gas valve. Turning off the gas valve, it removes the fuel. Okay, then you are in. Suppose that a fire occurs in a forest. Okay, so you can create a fire break or a fire barrier such that the fire from the adjacent trees can be cut off. Okay, and so that it does not spread towards the other areas. So that is these are some of the examples of how do we suppress the fuel element. Now, research is happening continuously in terms of fire science, and quite recently, okay, we have developed an advanced model of the fire triangle. So triangle has evolved into a tetrahedron. Okay, so a tetrahedron is basically you are having four sides. So the fourth element in the fire science is considered to be a chemical chain reaction. So if you see the fire triangle, we had three elements. We had oxygen, we had heat, and we had fuel. Now, as per the fire tetrahedron, we have a fourth element, and that fourth element is called as chemical chain reaction. It should be noted that the fire tetrahedron is considered to be more accurate when compared to the fire triangle. Okay, so let's see what is the chemical chain reaction. Now, as you see, once a fire is ignited, it keeps on taking place. Like if all the three elements are there, that reaction between all these three elements keeps on taking place. Okay, so it's basically a rapid, self-sustaining, non-static chemical reaction. Okay, so that is the chemical chain reaction. So as the fuel burns, it creates free radicals that continues to react. Okay, through this reaction, it generates more heat and it breaks down more fuel. Okay, thereby sustaining the fire. So that is about chemical chain reaction. So why does it matter? So some of the suppression methods work by interrupting the chemical chain reaction. So if you remove the heat, if you remove the oxygen, or if you remove the fuel alone, okay, it might not suppress the fire. So in order to suppress it effectively, you need to stop the chemical chain reaction. And for this, some of the suppression systems are, we have clean agent systems. So normally we have clean agent systems in the names of FM200, Novak 1230. Such systems form the clean agent gases. And then we have the dry chemical extinguishers, which is the normal DCP extinguishers, which we have, which is available, the multi-purpose extinguishers. So these interrupt the chemical reaction of the fire at a molecular level. Now, we have discussed the fire triangle and the fire tetrahedron. We have discussed what all are the elements of the fire. But what is the purpose of discussing these two models when you are talking from the perspective of a fire alarm system? So the reason why we discuss these two concepts is that we need to answer two questions. What are we detecting? Okay, and how do we stop it? So to answer the first question, what are we detecting? As I said before, a fuel has several byproducts. So in order to detect a fire, we are actually detecting these byproducts. So these byproducts are namely smoke, which are the particles, okay, heat, temperature, or flame. So for each byproduct, there's a separate set of detectors. We have the smoke detector, we have the heat detector, and we have the flame detector. Now, how do we stop it or how do we suppress it? So in order to stop it, there are various elements. So for example, in order to remove the heat, we can use water. We can discharge water towards the fire. In order to remove the oxygen, we can discharge CO2, carbon dioxide. And in order to break the reaction, we can use the clean agent gases, okay, or the multi-purpose dry powder extinguishers. And in order to remove the fuel, we can shut off the valves. Okay, this is an example, okay, on how to suppress the fire. So you need to understand that different detectors and suppression systems target different sides of the triangle. Okay, so it's like they actually, in order to cut off the fire, in order to extinguish the fire, they actually attack one particular element of the fire, so that when you remove that element from the fire equation, the fire is extinguished. Okay, so to summarize, a fire needs three elements. We have oxygen, heat, and fuel. So if you remove one, the fire is extinguished, the fire is gone. We discussed initially about the fire triangle. In the modern days, in the modern times, the fire triangle is evolved into a fire tetrahedron. And the fourth element of the fire tetrahedron is called as the chemical chain reaction. Okay, so the chemical chain reaction ensures that the fire is ongoing, it is sustainable. Okay, it is self-sustainable. Okay, so this model, that is the model of the fire triangle or the fire tetrahedron, is the science behind, explains the science behind every fire detection and fire suppression system. So I hope all of you have got an understanding of what fire triangle or fire tetrahedron is. So in case if you have any questions regarding to fire tetrahedron or the fire triangle, you can you can ask them in the comment section so that I can answer your queries. And you need to note that, kindly know that the next topic in this series is about the basic system types in the fire alarm system. So we have two systems. One is the conventional, and the other one is addressable. So we'll be discussing both these systems in detail in the next video. Okay. So in order to learn more, in order to follow the series in a regular basis, I kindly request you all to like, share, and subscribe. Okay. And thank you for listening, and see you in the next video.